The margin of error formula is used for two things because it only has two variables that can be found. One of them is the sample size, n, and the other one is the margin of error itself, me. This margin of error formula over here in black has been filled in asking for a 2.75% margin of error to find out what sample size would be required to achieve that. 1,270 people are enough to give you a margin of error of 2.75%. Our sample size is 1,270. But what the margin of error formula doesn't take into account is the size of the population. It doesn't seem to make very much sense that 1,270 people gives you the same margin of error for a population of 5 million as it does for a population of 4,000. And it makes even less sense to tell someone that they need a sample size of 1,270 if their population is even smaller than that, like this population of 1,000. 5 million might be a reasonable population for a state or a province or even a country. 4,000 might be a reasonable population for a college or for a small town. And 1,000 might be a normal population for a high school. What we need to do in order to figure out what sample size we really need is we have to fill in a second formula that looks like this. This formula corrects for the fact that population isn't taken into account in the first formula. And the p is the variable that stands for population. The n is the sample size we already have, the 1,270. Filling this in for a population of 5 million, the simplification will look like this. We plug the n equals 1,270 into two different places, and the p equals 5 million. And gradually, as we simplify, we end up with a rounded off value of 1269.68. But of course, in a sample, we need to interview whole people. We cannot interview 0.68 of a person, so we have to round it off to the nearest unit. And what we're getting is 1270. This makes sense. It means that a population as large as 5 million, 1270 is actually a large enough sample size to achieve the 2.75% margin of error that we wanted. Now let's try it again with the population of 4,000. Filling in the formula, our simplification looks like this. It results in a sample size of 964.13, which has been rounded off. But we have to round it off further. And we are finding out that we need a sample size of 965 in order to ensure that 2.75% margin of error. We have to round up, because if we round down, like we normally would, to 964, it's going to give us a margin of error that's slightly larger than 2.75%. And then we see something that makes a little bit more sense, which is for a much smaller population, we need a much smaller sample size in order to achieve the same margin of error. But the 965 is a much greater portion of 4,000 than the 1270 is of 5 million. As you get to smaller and smaller populations, you need a proportionally larger and larger sample size in order to achieve the same margin of error. Now let's try this other situation where our population is actually smaller than the sample size that's been recommended. Plugging that into the formula and simplifying, we get 559.72 as our sample size, which has already been rounded off, but must be rounded off further to 560. And for a population of only 1,000, 560 people is sufficient to achieve the 2.75% margin of error. I make sure that my students compare several population sizes in this way when they are using the margin of error formula, because by itself, the margin of error formula, as shown in black, doesn't make very much sense. And I find that students do not retain information very well if it doesn't make sense. Looking at these special cases and using the second formula makes the entire thing start to make sense, and that makes it easier for the student to remember. This is how we correct our sample size when using the margin of error formula in order to account for different size populations.